Hello everyone. In this video, we are going to discuss about the exercise question 3.12 from the chapter Motion in a Straight Line of class 11 physics. Let us go through the question first. A ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between t equals 0 to 12 seconds. So let us first write what all things are given as per this question. You see a ball is dropped from a height of 90 meter. Suppose the ball is initially somewhere here. This is the floor. So this height, initial height is 90 meter. Okay, that is the ball is initially at a height of 90 meter above the floor. Then it is dropped from a height of 90 meters. So its initial velocity, that is when this ball is here, its initial velocity v0, or you can take it as u, which is equal to 0 meter per second. Okay, then it is dropped from this height. So definitely it will come down. We know that it will come down and it will strike the floor. Okay, so and it is given that at each collision with the floor, the ball loses 1/10 of its speed. That is, you see the ball has dropped from a height of 90 meter. So its initial velocity is equal to 0. With some final velocity, it will be touching the floor. It will be colliding with the floor. And after the collision, definitely the ball will go back. Okay, but when this ball go back, its speed will be 1/10 of its initial speed. That is, it will be having some speed somewhere here. No, when it touches the floor, it will be having some speed. Then 1/10 of that speed will be the initial speed of this ball when it rebounds back in the upward direction. We want to plot the speed time graph of its motion between t equals 0 and 12 seconds. So you see, as per the question, it is very clearly given that its initial velocity v0, or you can take it as 0, which is equal to 0 or 0 meter per second. Then initially it is at a height of 90 meter. So its displacement x, or you can take it as s, which is equal to 90 meter. Then we don't know its final velocity, that is the velocity with which it touches or colliding with the floor. I'm taking it as final velocity v. So we want to find out this. Okay, now you see, when it is falling down, it will be in the free fall motion. So its acceleration a will be equal to the acceleration due to gravity. Okay, and here I'm taking, that is I'm choosing a coordinate system in such a way that, you see, I'm taking this point as the origin, positive axis, positive y-axis, negative y-axis. That is, the directions which are directed in the upward direction will be taken as positive, and the values or the quantities which are directed in the downward direction will be taken as negative. So we are choosing one such coordinate system here. So now let us just find out the time taken by the ball to hit the ground. Okay, let us first find out the time taken by the ball to hit the ground or hit the floor. Okay, that is what will be the time taken by the ball to come from here to reach here. Okay, so I am taking that time as t. So we want to find out that time t. So for that I am using the second equation 4. Which is one of the three kinematic equations of motion. That I am using this equation which is x equals v0 t plus half a t square, or you can use this equation s equals ut plus half a t square. Both are the same. Instead of s, I just took x here. Instead of u, I just took v0 here. That's all. Okay. So here we want to find out the time t. So you see, x, it is given as 90 meter. Okay, but you see, x is the displacement. The ball is, you know, it is falling from a height from here to here, that is in the vertically downward direction. So displacement, it is directed in the vertically downward direction. Vertically downward direction is taken as negative, so you have to take it as minus. So minus 90 equals v0 is the initial velocity, which is 0 here. 0 into t will give you 0. Okay, plus half a t square. But you see, a is the acceleration, which is the acceleration due to gravity here. We know that acceleration due to gravity, it is always acting in the vertically downward direction, which is along the negative y direction. So that must be taken as negative. So a will be minus g. So minus half g t t square. Okay, now this can be written as what? Minus 90 equals minus half g is 9.8, then t square. Okay, see, minus minus, we can cancel these two minus, no, that is when you take this minus here, it comes to the denominator, so minus divided by minus, it becomes plus. So this can be written as 90 equals half into 9.8 into t square, or you can write 90 into 2 divided by 9.8 is equal to t square. Okay, you can write 90 into 2 divided by 9.8 is equal to t square. Now when you do this calculation, 90 into 2 divided by 9.8, you will get approximately 18.37, which is equal to t square. Okay, so you see t square is equal to 18.37. So t will be what? Square root of 18.37. Time is always taken as positive, no? So no need of plus or minus a square root. Okay, just square root of 18.37. This will be approximately equal to 4.29. It is the time, so SI unit is second. Okay, that is we are getting the time taken by this ball to come from this or to fall from this height to touch this floor. That is the time taken by the ball to come from here to here. That time is 4.29 second. Okay. Now let us find out the final velocity v, which is the velocity with which the ball touches the floor first time. So let us find out that velocity by using the this equation, v equals v0 plus at, which is one of the three kinematic equations of motion. So here you see v, which is the final velocity which we want to find out. v0 is the initial velocity 0. Acceleration, which is acceleration due to gravity g, in the vertically downward direction, so taken as negative, so minus gt. Okay, so v equals what? V equals minus g into t. So now just substitute the values. V equals minus 9.8 into t, which is 4.29. So when you do this, you will get approximately minus 42.04 meter per second. It is the velocity, you know. This negative sign shows that the velocity is in the downward direction. Okay, so the velocity with which it touches the floor, that is the final velocity v. This velocity is 42.04 meter per second. Okay. That is, with this velocity 42.04 meter per second, the ball will touch or the ball will collide with the floor for the first time. Then after the collision, it is given in the question that the ball rebounds back by losing 1/10 of its speed. Okay, so it will rebounds back. The ball will rebound back, okay, with a velocity. I'm taking that velocity as v0r, which is the initial velocity in the second case. Okay, it is the rebound velocity of the ball, and that rebound velocity of the ball, which we have taken as v0r, that is equal to what? The ball loses 1/10 of its speed, means the rebound velocity will be 9/10 of the 9/10 of this speed, 42.04. Okay, so you can find out the rebound velocity v0r as 9/10 of this velocity, which is the final velocity of the ball in this case. Okay, that is 42.04. So when you do this calculation, you will get this rebound velocity of the ball as, when you do this 9 into 42.04 divided by 10, you will get approximately 37.84 meter per second. Okay, that is the velocity with which the ball first collides with the floor is 42.04 meter per second, and it is given in the question that after the collision, the ball loses 1/10 of its speed. So when it rebounds back, it will be rebounding back with a velocity which is called as the rebound velocity v0r, which is equal to 37.84 meter per second. So when we consider this case, this 37.84 meter per second is its initial velocity. Okay, then it will reach its maximum height. Suppose it reaches till here. Okay, so at this particular point we know that its final velocity v will be 0 meter per second. So let us find out the time taken by the ball to reach its maximum height. Okay, so let us find out the time taken to reach from here to here. So to find the time taken by the ball to reach this particular point, that is the maximum height in the second case, I am using this equation, which is v equals v0 plus a into t, which is one of the three kinematic equations of motion. Okay, or v equals u plus at. So in this case, you see the final velocity v0. Okay, the ball is going up. Its initial velocity, which is the rebound velocity, which is 37.84. A is the acceleration due to gravity. The ball is going in the upward direction, but acceleration due to gravity, which is always in the downward direction, which is along the negative direction, so you have to take it as minus. A, which is acceleration due to gravity, 9.8 into t, that is what we want to find out. Okay, so when you take this minus 9.8 into t to this side, that becomes plus. So 9.8 t equals 37.84. Then from this you can write t equals 37.84 divided by 9.8. Now when you do this calculation, you will get it as approximately 3.86 seconds. Okay, that is the ball will rebounds back and it will reach its maximum height in 3.86 seconds. So what is the total time taken by the ball to reach this particular point? First it took 4.29 seconds to come to collide with the floor first time. Then it took 3.86 seconds to reach here. Okay, so the total time will be equal to what? 4.29 seconds plus 3.89 seconds. Sorry, 86 seconds. So the total time taken by the ball to reach this particular point will be 4.29 seconds plus 3.86 seconds. When you add these two, you will get 8.15 seconds. So when the time t is equal to 8.15 seconds, it reaches this particular point. Alright. Now you see, as the time of ascent is equal to the time of descent, the ball will take the same 3.8 seconds to strike back on the floor for the second time. Okay, that is, it reached its maximum height here, then it will come back and it will collide with the floor now. Okay, and it will take the same 3.86 seconds to come back here. Okay, so when it is coming back, you see its initial velocity v0, this will be equal to 0 here, and you see with what velocity it will collide with the floor. So to find out the velocity with which it touches the floor, it collides the floor this time, we can use the same equation, v equals v0 plus at. In this case, the third case, initial velocity is 0. We want to find out the final velocity v. A is minus gt. So v equals minus 9.8 into t, which is almost 3.86 seconds. So when you do this calculation, you will get almost minus 37.83 meter per second, or it is almost equal to this velocity, 37.84 meter per second. Okay, so this negative sign actually shows that the velocity is in the downward direction. Okay, so here the velocity will be 37.83 meter per second. Now again you see, after this collision, the ball will go back by losing 1/10 of its speed. So what will be its speed now? What will be the speed? That is the rebound velocity, or what will be the rebound velocity of the ball this time? So this time you see the velocity with which it collide with the floor is 37.83 meter per second. It loses 1/10 of the speed, then it rebounds back. Okay, so now this time the rebound velocity will be what? This rebound velocity v0r will be equal to 9/10 of, that is, it loses 1/10 of, 1/10 of the velocity or 1/10 of its speed. So its velocity or its speed will be what, 9/10 of that speed, which is 37.83. So when you do this calculation, you will get it as approximately 34.05 meter per second. That is, this rebound velocity will be 34.05 meter per second. Okay, now you see the time of ascent is equal to time of descent. So what happens? With the same, by taking the same time 3.86 seconds, the ball will reach somewhere here, its maximum height. Okay, so what is the total time now? So first 4.29, then 3.86. Okay, which is actually equal to 8.15. Then 8.15 plus this time 3.86. Alright, so 8.15 plus 3.86 will be what? 12.01 seconds. So 4.29, when we add these two, we will get 8.15 seconds. Then when we add these three, we will get 12.01 second. Then when you add this two, you will get an total time will be different from this. In our question, we are asked to plot the speed time graph of its motion between t equals 0 to 12 seconds. So this 12.01 second is enough for us. So you see, to plot the graph, we want to plot speed versus time graph, no? So you see, when t equals 0, its speed is equal to 0 meter per second. When t equals 4.29 seconds, its speed becomes almost 42.04 meter per second. You see, at the same time, it loses 1/10 of its speed. At the same time, its speed becomes 37.84 meter per second. And after, by taking another 3.866 seconds, that is total 8.15 seconds, its speed becomes 0. That is, when t equals total time equals 8.15 seconds, its speed v becomes 0 meter per second. Then in the another 3.86 seconds, it comes back and collides with the floor. So the total time is 12.01 seconds. That is, when t equals 12.01 seconds, its velocity becomes 37.83 meter per second. We want to plot the graph for time t equals to 0 to 12 seconds only. So we want to consider only this much part of this. So here you see, I have considered the speed values in meter per second along the y-axis and time values in seconds along the x-axis. And I just marked these points as 4, 8, 12, 16 like that, then 34, 36, 38 like that speed. So when t equals 0, speed is equal to 0. So this particular point. When t equals 4.29 seconds, its speed first becomes 42.04 meter per second. So suppose this point corresponds to 4.29. Then speed will be 42.04. I'm just taking this particular point as that. At the same time, it loses its 1/10 of the speed, and its speed becomes 37.84 meter per second. So at the same time, we can consider a point somewhere here, which is almost 37.84 meter per second. Then you see, when t equals 8.15 seconds, I'm taking somewhere here a point, speed becomes 0. So 0 means this particular point itself. Okay, so this point, first, second, third, then fourth. When t equals 12.01, almost here, its speed becomes 37.83, so somewhere here. Okay, so when we join all these, we will be getting the graph. So from here to here. Okay, then join these two, then third, then here. Okay, so this will be the speed versus time graph for this question. So you see, in this question, we have discussed about the exercise question 3.12 from the chapter, motion in a straight line of class 11 physics. I hope it is clear to you. Thank you.